Hey folks, welcome to the next class in the series of Basics to Advanced, where in this session we'll be talking about time and work. But time and work happens to be one important topic. You almost get a question from time and work every time. So we call it to be one of the most important topics when it comes to arithmetic. A simple topic, simple logics to apply, and then we are through with it. So in this class we'll talk about a bunch of things here. We're going to talk about working with different efficiencies. Then we'll talk about fractional method, the percentage method or fractional method, and then we'll talk about LCM method, and then we'll have some ideas about pipes and systems. We'll do mandates, and then we'll solve a few questions, some important questions from CAT. So to begin with, working with different efficiencies. So what is the basic idea behind this? Now, the fundamental logic, the fundamental assumption behind time and work is that when we say someone, let's say A can finish a work in X days. X could be anything. If I say I can finish a work in 2 days, if I ask you what is the amount of work done in 1 day, your mind would automatically say 50%. Now, why is that 50%? Now, if I can do a work in 2 days, first day 50%, second day 50%, that's the total work. Oh, sometimes we don't work on that principle. If there are 5 days to complete a task, we finish the work, we start the work only on the 5th day. That's basic thing that we do. But when we solve a question, when we plan something, if I give you 5 days for your semester to prepare for your semester, and then I say there are 5 units, your fundamental assumption would be to start with, okay, I'm going to do 1 topic a day. That's an assumption that we have. That's a plan that we think on executing. Do we do that? Is a story to talk on some other day. But to begin with, our understanding is that on every given day, the work done is equal. So if I say A can finish a work, where if I say X is equal to 10 days, first day, we think that I'm going to finish 1/10 of the day, or 1/10 of the work, or 10% of the work. You can either do it as a fraction or a percentage. So sticking with fractions is relatively easy. We have seen that over time. Looking at percentages as fractions is a lot easier way to solve questions. Second day, you will say I'll do another 1/10, which is another 10%, or 20% total done in 2 days, right? If I do third day, 30%, fourth day, 40%, 4/10. If I do 10 days, it will be 1/10, 1/10, 10 times, or 10 into 1/10, which is equal to 1, or we call it 100%, or 1. So total work here in this method is 1. This is what we call it as the fractional method. A standard method, standard procedure to solve questions and time and work happens to be fractional method. So this is the crux of the entire method. We assume the total work is 1. It's a simplified version of 100%. Instead of calling 100%, we call it 1. The total work is always 1. And the amount of work done on any given day throughout time and work questions is always equal. On any given day, for any person, for that particular person, will always be equal. This is a assumption that we have. This is a structure that we have when it comes to fractional method. So we use this to solve a couple of questions to get better. We'll take an example so that we understand this. If I say, there's a question that says A can do a work in 12 days and B can do the same work in 24 days. And how many days will they complete the work together? So by data, A takes 12 days. From here I can say 1/12 each day. If I take B, B takes 24 days to complete the same work. Now that will be 1/24 of the work each day. Now we know if both of them work together, number of days taken gets reduced, right? More the people working on a task, lesser the time they take. That's the concept that we have. So if both A and B work together, A plus B, that will be 1 by 12 plus 1 by 24, right? 1/12 completed by A and then 1/12 completed by B. So 1 by 12 plus 1 by 24. So that will give me an LCM of 24, 1 plus 2, right? Or 2 plus 1, 2 by 24, 1 by 24. That will give me 3 by 24th of work per day. Or from here we can simplify it and say 1/8 of work per day. What do you mean by 1/8 of the work per day? Which means that if both A and B work together, they can complete 1/8 of the work in one day. So total time taken, total time is equal to reciprocal. We understand that time reciprocal is efficiency, efficiency reciprocal is time. So time and efficiency are inversely proportional. More the time you take, lesser the efficiency you have. More the efficiency you have, lesser the time you take. So 1/8, we take the reciprocal of that, it will give us 8 days. And that will be our answer. Simple idea to begin with. That's your basic way of solving this question. Most people stick with fractional method because they are comfortable doing it. But sometimes for some of us, dealing with fractions becomes a pain in the neck. We sometimes don't want to deal with fractions. We want to understand the numbers in a better way. In those cases, how do we attempt a question? Now, to give you an example, if I say, had the question been this easy every time, I don't think fractional method will have a problem. It's not really a problem had this been the case. But sometimes you don't get questions where it's pretty straightforward. A and B together, they complete a work. How long will they take? Fractional method or any other method is going to be simple. But look at this question now. A can complete a work in 24 days, B in 16 days, and C in 12 days. After working together for 2 days, C leaves. In how many more days will A and B finish the remaining work? How many more days will be taken? If I have to do that, A is equal to 24 days, B is equal to 16 days, C is equal to 12 days. From here, this is 1 by 24th, 1 by 16th, and then 1 by 2. We have this. All started working together. After working together for 2 days, A plus B plus C. C leaves, which means for the first 2 days it was A, B and C. But after this, C has left. So how do you solve this question? A plus B for the remaining time. But we don't know how many days it is. How do you do this? I'll have to write an equation that fits here. So that will become 2 days of 1 day of A, B and C would be 1 by 24 plus 1 by 16 plus 1 by 12. This is 1 day's work, but we need it for 2 days. So into 2 plus A's 1 day's work is 1 by 24. B's 1 day's work is 1 by 16, but we don't know for how many days. So I'm going to call X days. All put together, they have completed the total work, which will be equal to. If you solve for this equation, we get the value of X, and that's our answer. So let's have one crack at this. So what is the LCM here? 24, 16, 12 will become 48. So 48, this is 2, this is 3, this is 4 into 2. Plus again, this will become 48. So will also be 48. So this will be 2 plus 3 into X is equal to 1. So take the LCM, add this. 2, 3, 4 is 9. 9 into 2 is 18. So 18 plus 5x, 2 plus 3 into x divided by 48 equal to 1. 5x plus 18 is equal to 48. If I take that 18 over there, 5x is equal to 30, x is equal to 6. And there we have our answer. Nice and easy, nice and simple. I find this to be super painful. Too many equations to write, too many steps to solve. It doesn't happen to us conveniently in a comfortable zone, especially when it comes to an exam situation. There should be a better way, right? This is where we introduce a concept called the LCM method. So I'm going to solve the same question under the LCM method now. What is the LCM method? Now all this while we said the total work is 100%. We said there is some work done, but we don't know the amount of work to be done. So what we are going to do is, instead of taking as percentage, we are going to assume an amount of work. What is the amount of work? It could be anything. You could take 100 units to be completed, 50 units to be completed, 7 units to be completed, X units to be completed. It doesn't matter how many units we take. But for our convenience purpose, what we are going to do is 24 days for A, 16 days for B, and 12 days for C. What we are going to do is, we are going to say total work is going to be LCM of 12, 16 and 24. It will be 12, 16 and 24 units. The LCM of that will be 48 units. From here it gets a lot easy, because you can even use your mind calculation to solve the question, because we are going to deal with integers here. What do I mean here? So if I take the timeline again, the first 2 days has been A, B and C, and the last set of days was A and B alone. Now A is capable of completing 48 units in 24 days, which means he is capable of doing 2 units per day. What about B? 48 units in 16 days, it will be 3 units per day. 48 units in 12 days, C is capable of doing 4 units per day. Right? Now we can think about the idea here. A, B and C worked for 2 days together, which means 2 days of 2 plus 3 plus 4. A completes 2 units, B completes 3 units, C completes 4 units in 1 day, and that has happened for how many days? It's going to be for 2 days, which will become 18 units. But we know the total amount of work to be done is 48 units. 18 units already done. So where is the remaining set of units? It's sitting over here, which means A and B together should be completing 30 units. Now I look here, A and B is capable of doing 5 units per day, and they have to complete 30 units. So how many days will they take? 30 units by completing 5 per day would have given us 6 days. So we get the same answer as before, get 6 days. So the question is, how many more days will A and B finish the remaining work? The answer is 6. Beautiful idea. You just stick with numbers. All you have to do is find the LCM, find the individual efficiency. If you can plot the timeline and you can fix every data that we have, we simply have all our solutions in a very easy fashion. So the decision to choose LCM method or fractional method is with you. In some questions, fractional methods are nice. When I don't know the values, I probably stick with fractional method to solve the question. And most of the times, I use LCM method. Which method you want to use depends on how comfortable you are with the method. So choose wisely while solving question. And how do you get to know which is better? You keep solving questions over and again to understand which method works where and which method is better in what position. You'll get to know when you solve more questions. So we'll be doing a few questions here to get an understanding of that. So let's solve a couple of questions before we sign off. So I'm going to solve a couple of questions. I'm going to give you a minute to take a snap of this so that you can solve it before we start. Let me move aside. And let's solve. A can do a work in 10 days, B in 12 days, and C in 15 days. All three start working together, but after 2 days, B leaves, and after 2 days, another 2 days, C also leaves. And how many total days will the work be completed? So same method, let's do it. A is equal to 10 days, B is equal to 12 days, C is equal to 15 days. So the total work, let's take it to be 10, 12 and 15. LCM will be 60 units. So A can complete 6 units per day, B can complete 5 units per day, C can complete 4 units per day. So let's draw the timeline here. All three started working together, but after 2 days B leaves, which means for the first 2 days it was A, B and C for 2 days. After 2 days B leaves, which means at some point B has left, leaving us only with A and C. And after another 2 days C also leaves. So B left after 2 days. 2 days later C also left. That means in this gap A and C has worked for 2 days, and after this it has been A all alone by himself, but we don't know how many days he has worked, which we'll find, not a big deal, right? So if I say 2 days of A, B and C, they are capable of completing 15 units per day. So in 2 days they would have completed 2 times of 50, which is 30 units per day, 30 units in 2 days overall. That's done. Now A and C is capable of completing 6 and 4, that's 10 units, and they are working for 2 days, so which will be 2 times of 10, which will give us 20 units. If I notice these set of 4 days, we have already completed 50 units. So what is left out? After this it is only A. What does it mean? A is going to work for the remaining time to complete how many units? He still has 10 units to complete. And what is A capable of doing? A is capable of completing 6 units in a day. So he would take 10 by 6, which will be 5 by 3. That will be 1, 2 by 3 days. 1, 2 by 3 days is what he would take. Sorry. So the question that's asked here is, in how many total days will the work be completed? So what is the total amount of work done? 60 units. In how many days? 2 units of A, B and C, 2 units of A and C, and then 1/2 of a day of A alone. So that will be 2 plus 2 plus 1, 2 by 3. I can call it 5, 2 by 3 days. Or you can call it 17 by 3 days. Either way, so it depends on which option you have in your question. So 5, 2 by 3 or 17 by 3, both happens to be the same. So ensure that you plug in your data right, you get your timeline right, because you make a mistake with your timeline, everything collapses. So the fundamental has to be there to solve the question, right? So we'll move on to the next question. Have a look at this. So let's do this now. A can complete a work in 16 days and B in 24 days. They begin the work together, but every alternate day only A works alone. And how many days will the work be completed? Beautiful question again, simple. A is equal to 16 days. B is equal to 24 days. The first thing that we'll take is total work. LCM of 24 and 16, 48. 16 into 3 is 48. Can take 48 units. So this will be 3 units per day, 2 units per day. So we understand that on the first day it's A plus B. On the second day it is A alone. Why? On every alternate day only A works, which means they both start the work, but the next day it is A alone. Again we have A plus B, again A. On every alternate day it is A alone working. So B joins him on every alternate day again. Right? So in the first day it will be 3 plus 2, that's 5 units done. Second day it is 3 units of A. Third day again 5 units and then 3 units, and it keeps going. I notice that in one cycle, I'm going to call a repetition as a cycle. One cycle we have 2 days, and in the same one cycle we are completing 8 units. So for every cycle I'm getting 8 units now. So think about this. How many times do I have to do 8 units? so that we have to go to 48. 8 into 6 is 48. So I can say 8 units into 6 cycles is equal to 48 units. Right? What is a cycle? One cycle is equal to 2 days. So 6 cycles will be 12 days. For the question, in how many days will the work be completed? Straight away you can do 12 days. And that's our answer. This sounds super easy, but sometimes questions like these will have a trap, and we'll figure out what trap that is in the upcoming class. But to begin with, that's how you do the question. Right? We'll do one more. Let me step aside. So to solve this question now, P and Q can complete a task in 20 and 25 days respectively. They both start a task together, and after few days P leaves and Q completes the remaining task. If it took a total of 15 days to complete the task, what portion of the work was completed by P? What portion of the work was completed by P? So let's do this. So P is equal to 20 days. Q is equal to 25 days. Total work will be 100 units. 20 and 25, the LCM is 100 now. So P is capable of doing 5 units per day. Q is capable of doing 4 units per day. By condition, they both start the work together. They started it together. So for some period of days, it has been P plus Q. But after a few days, P leaves, which means it is only Q. And Q completes the remaining work. It has taken a total of 15 days. So entire period is 15 days. What portion of the work was completed by P? Let's do this. There are a couple of ways to solve this question. One, I'm going to write an equation and solve. I'm going to say P worked for X days. So Q alone worked for 15 minus X days. We can write an equation. For X days, both P and Q worked, and they would have completed 9 units per day. So for X days, they would have completed X into 9. Plus for 15 minus X days, it was only Q, which is 4 units. And by doing so, they complete 100 units, right? Number of units into days is total units. Number of units into days, again total units. At both cases, you have to go to 100 units, right? So let's solve this. 9x plus 15 into 4 is 60 minus 4x is equal to 100. 5x is equal to 40. X is equal to 8. That means P worked for 8 days. Q alone worked for 7 days. So 8 days of P and Q together, 7 days of P alone is our value. But the question is, what portion of the work was completed by P? So how do I find portion of work completed by P? Days worked by P into units worked by P. So P is capable of completing 5 units in a day, and then he works for 8 days, which means he potentially finishes 40 units of the total work. What is 40 units? Out of 100, you either say 2/5 of the work or 40% of the work. Either way, the answer is right. Again, it depends on what answer option that we have. Simple idea to work with. But the other logic that I sometimes use is, I notice that Q has worked for all 15 days. Q has worked for all the 15 days. From start till the end, Q has worked, which means Q worked 15 days. And that's the total, that's the maximum that he could work. If he works all 15 days, he would have completed 15 into 4, that is 60 units. I noticed that if Q worked for all 15 days, he potentially would have finished 60 units. But the total work is 100 units now. What are the remaining 40 units? Who would have completed that? The only possibility that we have is P completes the remaining 40, right? He should have completed the remaining 40 units. So how many days that he would take? Days will be this 40 divided by he can complete 5 units in a day. That will give us 8 days. This is another way of looking at the solution. That's your conventional way to do. This is simple logic that you can sometimes deploy. It depends on how comfortable you are. Stick with this. Gradually transition towards logic. Your funda is mandatory. Your application, your layered application comes later. Start here and gradually transition towards here, and you will start feeling a lot better when it comes to questions in time and work. So get to the basic properly, learn the concept once again, solve a few basic questions and then see how it lands you, and gradually we'll move on to the next class and then we'll start solving some trickier questions. So the next class we'll talk about man days and pipes and systems. But in the meanwhile, if you understand what it is to solve time and work, solve this question, have a look at it, try to solve it either by fractional method or LCM method. Both ways will work. And then if you have gotten the answer, drop your answers in the comment box. And yes, don't forget to join the Telegram channels where we share all the important notes. Whatever it is that you need to know for your preparation comes over there. Don't forget to share. Don't forget to drop your comments. Don't forget to join. And yes, don't forget to prepare intensively for your CAT. All the best.